Hello guys, how are you? My name is Chandan Kumar Jha, and now we are going to discuss a new subject that is called EMFT, Electromagnetic Field Theory. But as we know, that is a we have very short time. So quickly, I'm going to brief idea, or I'll give you the brief idea related to the EMFT and how to study the EMFT. In today's class and tomorrow class, I'll discuss that is EMFT into some points. But before going on the subject, I'll tell you something about me. My name is basically the Chandan Jha, and I have 9 years plus 9 year experience. Cracked the ISRO examination. I'm the MTech in the communication and networks. And apart from the teaching, I'm also taking this motivational session including the various colleges of engineering, including NITs and IITs, right? My expertise subject is basically digital circuit, control system, signal and system, communication, and the microprocessor is my core subject which I frequently deal with, right? Now, that is the basically days, total 68 days are remaining for the GATE examination, right? So be focused, utilize the time. 68 days, right? Just plan yourself or your daily routine according to the 68 days. That is the syllabus of electromagnetic field theory, EMFT. In the EMFT, the syllabus is basically, the first is the vector analysis. After the vector analysis, that is the electrostatic field theory, right? That is electrostatic. After that, the magnetostatic field. After the magnetostatic, we'll discuss the boundary condition and Laplacian. Laplacian is nothing, it is just a form of what? There are two things. It is the extension version of the Poisson, right? We know the Poisson equation, and after if del square v equal to 0, then it will become the Laplacian, right? We'll discuss this thing in separate portion. After that, we'll discuss the Maxwell equation, right? After that, the uniform plane wave. After that, polarization, reflection and refraction. After that, that is the transmission line. That is very, very important for the GATE point of view. We can expect one question from the transmission line also, right? Now, waveguides. Waveguide is also important, right? Some question related to cutoff frequency will be asked from the waveguide. We'll discuss that question. Antenna and wave propagation and optical fiber and radar. Now, I am not going to discuss optical fiber and radar for the GATE examination. Yes, but we'll discuss the optical fiber and radar for the mission ISRO. Actually, I'm splitting the whole syllabus into 3 parts, right? As we know, the EMFT is very vast syllabus, right? We'll not cover the electrostatic even in the 10 hours, right? Even electrostatic itself take around 20 hours, right? So it is a very vast syllabus. That's why I'm splitting this EMFT into 3 parts, right? One is the basic from the Maxwell. Second one is uniform polarization and transmission line. And third part is waveguide, antenna and radar, right? In this class, we will discuss first portion, that is called vector analysis, electrostatic field, magnetostatic field in very brief, right? Magnetostatic, boundary condition and Laplacian and Maxwell equation. But in the tomorrow class, we'll discuss the uniform plane wave, what is the polarization, what is reflection, right? And the transmission line we'll discuss in the tomorrow class, that is in the second section. And the waveguide, antenna and wave propagation and the optical fiber we'll discuss, that is third part. We'll discuss this thing in mission ISRO. We'll discuss this thing in mission ISRO, right? Yes, one question. Sir, what are the important topic? Yes, Pooja, the important topic is basically I have splitted the EMFT into the 3 parts. First part is 1, second part 1, and that is third part. We can expect at least 1 or 2 questions from each part, right? Each part having the equally weighted, in the equally weighted according to GATE examination, right? I have divided into 3 parts. But yes, the most important part, or we can for the ECE student, we can expect around 10 marks question from the EMFT, around 8 to 10 marks question around the EMFT. Then we can expect 2 marks question from this portion, or 3 marks question from this portion, and around 5 marks question from this portion, right? that is the basically weightage around it can vary, but according to me, this topic will cover around 2 marks question, this topic will cover around 3 marks question, and this topic is very, very important. It will cover around 4 or 5 marks. We can say that around 4 marks question. We can again split into 3 parts, right? Sir, are you covered the power electronics? No, dear, I am not covering the power electronics. I am dealing with the EMFT right now, right? Okay. Nikhil Ranjan, what are you asking about? I am not getting your point. Nikhil, sir, microwave कैसा करूं? Sir, please guide. Krishna, हम आपको बताएंगे कि how to deal with the microwave in the mission ISRO. All the syllabus and plan basically that all the syllabus is basically the plan. Now it's time to execute. So आपने देखा होगा एनालॉग के अंदर भी हमारा सब्जेक्ट शुरू हुआ है. In the analog electronics we are dealing with a few topics which is very, very important for the ISRO. Just like that, we'll deal the microwave in very brief, so that you will get the maximum marks in the ISRO from the microwave, right? So don't get the tension regarding to that, right? Okay. Now we'll move on the topic for the ECE. First point, that is the vector analysis. I'm not going in very much of the detail about the vector analysis because it is a very easy topic and everybody knows about the vector analysis. So I'll discuss in very brief about the vector analysis. In the coordinate system, in the EMFT, the coordinate system is basically divided into 3 parts. One is the Cartesian system, another one is the cylindrical system, and the third one is the spherical coordinate system. So if we'll deal in the vector analysis for the Cartesian system, if there is a 3-dimensional coordinate system, there is the one is the x, another one is the y, and the third one is the basically z. Now, sir, one question, sir, how many lecture will take for the EMFT? Around 2 or 3 lecture. That is not basic, it is a quick revision class, dear. In the quick revision, I'll give the brief idea about the EMFT, and yes, in the brief idea or that we'll discuss in the class. According to that or according to that only, we'll cover the lots of question related to the gate, right? In the basic, if you know the basic concept of the EMFT, then definitely you will crack all the questions which are related to the EMFT if you have the basic knowledge, right? Because EMFT nothing, it is just a extension of your knowledge. If you know, we'll discuss this thing in later, right? First of all, the Cartesian system, that is also 3 coordinate system, x, y, and z, and we know that all the system is basically the right-handed system. If it is a right-handed system, it means if we'll move from x to y, then we'll get z. If we'll move z to y to z, then we'll get x, and if we'll move from z to x, then we'll get y, right? So that's why it is called right-handed system. If we'll plot or if we'll take any point in this plane P, then it is x, y, and z. That is the basically coordinate of that point, right? Okay, sir, actually I have completed this subject. So only problem is the radar and optical. Okay, dear, radar and optical is discussed in the, we'll discuss this topic in the micro, that is in the separate, that is mission ISRO. But at this time, I'm not covering the entire syllabus of the EMFT. I'm just giving the brief idea. That is just called, you can say that it is just a revision class, right? Now, in the Cartesian system, we'll move in the cylindrical coordinate system. So in the cylindrical coordinate system, there are 3 parameters. One is the rho, another one is phi, and next one is the basically the z. Just like this bottle, if any point is placed at this point, it is basically the cylindrical coordinate system. If any point is on the surface of this spherical, it's cylindrical, then we can say that distance from the center to the cylinder is basically rho. We can say that it is rho, right? Now, and the movement with respect to the front edge of this coordinate system is called basically phi. So if we'll move in this direction, then it will call basically the phi, and z is nothing, it is just like the Cartesian coordinate. So it has the 3 coordinate system. One is rho, another one is phi, and rest one is the basically z. If you know the 3 parameter, that is rho, phi, z, then you will get the every point in the cylindrical coordinate system. If we'll say it is nothing, it is just a phi, right? This coordinate system, if this point is nothing, it is just a phi. It is a phi, it is a rho. So we can say that it is nothing, it is just a rho cos phi, and it is nothing, it is just a rho sin phi. And z is nothing, it is just like the Cartesian coordinate system. So if we want to calculate the value of x, then x is nothing, it is just a rho cos phi, y is nothing, it is just a rho sin phi, and z itself is a z, right? Now, from this, if you want to calculate the rho, then you have to just square the signal, 1 x square, y square, and just add it. Then you will get rho square, and rho is nothing, it is just a root of this thing. And if you want to calculate the phi, just divide by these two things, you will get the tan inverse y by x, and z itself is a z, right? Now, there is also a conversion formula, but if you know the exact how the mapping will be done from Cartesian to spherical or Cartesian to cylindrical, then there is no need to memorize the formula. But if you want to minimize the time for the question, then you should memorize these formula, that is the conversion formula. If you have x, y, and z values that is in the Cartesian form, then by using this formula you can calculate or you can get the cylindrical coordinate. And if you want to calculate the Cartesian from the cylindrical, you have to take the inverse of this matrix. If you will take the inverse of that matrix, then it will become cos phi minus sin phi 0, sin phi cos phi 0, 0, 0, 1. So it is the basically conversion, but no need to convert by this formula. If you know the actual approach, right, then there is no need of this formula, right? Now, third one is the basically in the very quick manner, I am just briefing about this thing. Few topic I'll get in very much of the detail, but that is not, I think that is not that much important for the point of the gate examination, right? It is a spherical coordinate system. In the spherical coordinate system, you'll see, okay, before going to the spherical coordinate system, if you see in the cylindrical coordinate system, there are three things, rho, there is the three things that is called rho, phi, and z. If you want to find the value of rho, what is the basically the value will be rho in this coordinate system, then rho will be 0, because rho is nothing, it is just a radius. Radius will from 0 to infinity. Now if we move the phi will be nothing, it is just from 0 or we can say that minus pi to pi, or we can say that 0 to 2 pi. And if you will z, then it will become from minus infinity to plus infinity. It is basically the range of in which the value will be taken. How to prepare for the ISRO interview, sir? Nikhil will discuss this thing, don't worry about that. In the ISRO examination, the most important topic basically given by or asked regarding to satellite, analog electronics, and the communication, right? Satellite, analog electronics, and the communication signal system. This is the basic thing from which they will generally ask the question, right? Now, that is the spherical coordinate system. A spherical coordinate system is nothing, it is just like the Earth system, right? Like this. There is a three parameter, one is the r, theta, and phi. There is a three parameter that is called r, theta, and phi. If you want to calculate or if you want to see what is the r is nothing, it is just a distance from the origin, right? If you will see the ball or hollow ball, in the hollow ball, inside the hollow ball, the center of the ball is basically that one, and the surface of the ball is nothing, it is just a r, right? Distance, that is r, right? Now if you want to go through what is the theta, if you want to find out the theta is nothing, we can say that this sphere is basically formed by this small strip like this. This is the 0 degree, right? And so on, we can increase just like an onion, right? So we can say that that is the basically the r. That is the basically theta. It is the 0 degree. It is something around 10 degree. It is nothing. It is just a 90 degree, and so on, right? 90 degree, 45 degree, and it is yes, it is 90 degree. It is a 180 degree from this pole to this pole. So if we'll find the range of r may be from 0 to infinity because it is a radius. But if you want to go for the theta, then theta will be from 0 to pi only, because from this point to this point, then the last point you will move in the circular motion. So that is the theta. And if you want to find the value of phi, then phi is nothing again from this point. If you move the rotational motion, I'm taking consideration or I'm taking this example here. From this point, if you'll move in this side, then what is the basically angle? At what angle that point will be find out or that point will present is basically taken by the phi. So the value of phi is nothing, it is just a 0 to 2 pi. That is the basically the range of the spherical coordinate system. Yes, there is the formula also. How the spherical coordinate system is converted into the cylindrical and cylindrically converted into the Cartesian, everything having the formula. But by this formula, how that point is basically mapped, you will get every question or you will solve every question related to it, right? So I'm not going to very much of detail in this topic because all are aware about this topic. Now, for the quick revision, that is there is also a del operator, right? In the del operator is basically divided into two parts. One is the operation on the scalar, another one in the operation of the vector, right? In the del operator is basically divided into two parts. One is the we can operate the del in the scalar, another one we can operate the del into the vector. If we'll operate the del into scalar, then it is called the gradient. Then it is called the gradient. It means gradient is nothing, it is just a del f, where f is nothing, it is just a scalar. It is a scalar quantity. But after the gradient, okay, we'll discuss this thing. Now, what about the vector? If you will see the vector, so if you operate the delta on the vector del operator, or del operator is nothing, it is just like this. Del upon del x ax plus del upon del y ay plus del upon del z az. It means it will give the rate in the all the direction of the any function, right? It will just give the rate about all the direction. Yes, one question. Sir, ISRO syllabus is same, sir? Please tell me ISRO weightage. Dear Mani, we'll discuss the ISRO weightage in the ISRO mission class. It is a basically quick revision class for the GATE examination, right? Now, the vector operation, if we'll see the vector operation, then we can say that the vector is also, when we'll operate the delta on the vector, there are two parts. One is for the divergence, another one is called the basically curl. Divergence is nothing in the vector quantity. Let A is nothing, it is just a vector quantity. Or if we are performing the delta operation on it, then it will become delta dot A, right? And it is called basically nothing, divergence. And if you will move or if you will curl this vector with the delta, then it will called curl. That is called curl. So cross product basically gives about the nature of the rotation, and the dot product basically gives the nature about the increasing function in the, or we can say the radially outward functions, right? So right now in the that delta is basically we can we will write the delta in only in the Cartesian coordinate system like this, right? Now few points is very important for the line, volume and surface integral. If there is a coordinate system and here is the parameter and the scaling factor, if you want to do not memorize anything related to that, then yes, Ankita Kavla sir, 1 upon m the unit of delta. Yes, dear, 1 upon m is the unit of basically the delta, right? Yes, you are right. Okay, in the Cartesian, if the coordinate system, we can say that if I'll see, just like in the Cartesian coordinate system, there is x, y, z. In the spherical coordinate system, there is r, theta, phi. In the cylindrical coordinate system, that is rho, phi and z. Like this, we can say that there is the three parameter in the any coordinate system, that is u, v and w. U, v and w. And the scaling factor for that h1, h2 and h3. Then for these three Cartesian three systems, we can write the scaling parameter like this, right? In the Cartesian system, that is 1, 1, 1, and u is x, v is y and w is z. In the cylindrical coordinate system, u is rho, v is phi and w is z. Now in the spherical coordinate system, u is r, v is theta and w is phi, right? Now The scaling parameter for the Cartesian system is nothing, it is 1 1 1, and for the cylindrical coordinate system is 1 rho 1, and for the spherical coordinate system is 1 r r sine theta. So if you want to find the line integral for any function, so in the cylindrical, if I'll write the cylindrical, in the cylindrical the line coordinate system, line vector. In the cylindrical, the line vector is basically represented by like this. H1, what about the H1? That is 1 1 d rho a rho plus, for H2, what about the H2? Rho phi d phi a phi plus z dz, or not z actually, 1 dz and az, right? If we'll write, this thing is basically very useful, that is the volume integral, that is the scalar quantity. Yes, one thing more, line integral is always a vector, surface integral is always a vector, but yes, the volume integral is always a scalar quantity, right? One thing more, in the ds, in the surface form, if you want to write, then for the any spherical coordinate system, h1 into h3 dv dw au, h3 h2, you have the scaling value, h1 you have the value of h1 h2 h3, just put at this place and find or write this equation for the surface integral, right? Everything basically related to this table only. For example, in the spherical coordinate system, if you'll write the volume equation, then h1 h2 h3, what about the h1 h2 h3? Sir, h1 is 1, h2 is r, and h3 is r sine theta. Then it will become r square sine theta dr d theta d phi. That is the basically equation written for the what? Volume integral for what? For cylindrical coordinate system. So by using this matrix, you will get these three: line integral, surface integral, and volume integral. And it is very, very useful for what? It is very, very useful for the electrostatic as well as the magnetostatic. Because in the magnetostatic or electrostatic, lots of time we have to use the surface integral and the volume integral, right? Now, so the first of all, I have now, if you want to find out the gradient, and as we know, the gradient is basically the operator in which that is when the del operator is basically used for the in the function of scalar function f, then it is called the gradient. When it is operated on the vector quantity, then it has the two values, one is for the divergence, another one is basically the curl. So how to calculate the divergence, gradient, divergence and curl? That is given by like this. It is a short approach by which you can remember and you can find everything which is related to the gradient, divergence and the curl, right? So hope you are all familiar with this formula, right? Now we'll move. We know the value of h1, h2, h3. If you want to calculate the gradient for the any function, just use this formula. For the divergence, use this formula. And if you want to use curl, then use this formula for, right? And you should remember this thing, right? Because it is very useful also. Now we can say that for the Laplacian operation, Laplacian is nothing, it is just a what? Del square of any function, or we can say that del dot del of f. It is called nothing, it is just called what? Laplacian. For example, del square v, or we can say that this in the next slide, what is basically the practical application of this Laplacian and Poisson. We'll discuss this thing, but at this moment we can say that for the Laplace, whenever we have to use the Laplacian operation, should use this formula, because the function always written in the form of either in the Cartesian form or in the cylindrical form or in the spherical form, right? Sir, what about the ISRO exam? Actually, there are two type of courses basically going on in the YouTube. One is for the GATE examination, right? That is called quick revision class. And the second one is the mission ISRO. In the mission ISRO, we'll deal specifically for those topic which is very, very important for the ISRO examination. And in the GATE examination, we'll discuss the mostly that topic which is very, very important for the GATE examination. But in the EMFT, I have splitted whole the syllabus into 3 parts. 2 parts, part 1 and part 2 will cover in the GATE syllabus, and part 3, because in the part 3 I'll take some more time, right? That's why I will cover the lots of things. So antenna and waveguides I put in the 3rd group, and we'll discuss that 3rd group in the mission ISRO plan, right, Ravi Kumar? Now, few important topic related to the Laplacian, that is curl of the gradient. Curl of the gradient is always equal to 0. Another one, the divergence of the curl is always equal to 0, right? E is electric field. We know that electric field is nothing, it is just a minus del V, right? Irrotational, whenever you want to calculate or you want to prove the whether the function or the system or field is rotational or not, we have to use this equation. If the field is rotational, and there is a point, if we want to field is rotational, then there is a constant in this point. So if we will find the slope in this direction, because dot will give the radially outward directional slope, so you will feel the slope will become 0. So that's why del dot A equal to 0 will give you the idea the field is basically irrotational. And if the field is solenoidal nature, then del dot A is okay, irrotational, then this will become 0. And if the field is solenoidal in nature, then del dot A is basically 0. These two things, few questions will be asked in the GATE examination regarding to this one. These two topic, irrotational field and solenoidal field. We'll solve one question in the solenoidal field related to the solenoidal field in this class also, right? Now, so just write down or make a note for this. Curl, that is del cross gradient, or curl of the any gradient is always 0. Divergence of the curl is also 0, because it will give the rotational nature, and if you will give dot product, then it will get the radially outward. So radially outward of the rotational is always the 0. That's why it will become 0. We'll use this equation in the next slide also. E equal to minus del V, right? And there are two things that is related to irrotational field. Another one is related to solenoidal field, right? Someone asked, what is the solenoidal? Actually, whenever the anything is basically related to rotational in nature, then it is called the solenoidal, right? Then it is called solenoidal, right? Just like a magnetic field. Magnetic field is nothing, it is just a solenoidal nature. Now, just solve the question. One question, that is the basically the GATE question. The direction of a vector is radially outward from the origin, with a vector is nothing, it is just a k r raised to power n. Now, where r square equal to x square plus y square plus z square, where k is a constant, then what is the value of n for which del dot a vector will become 0? And del dot a vector will become 0. We have seen this thing, del dot a vector will become 0 when the field is what? Solenoidal. So by this question we can say that this is the basically nature of what? Solenoid. Solenoidal nature, right? This thing basically related to solenoidal nature. Now if we want to calculate, first of all, there are two approach, right? First we have to solve in the Cartesian. Another one we have to solve in the there is the r, so in the cylindrical also, in the spherical coordinate also. Right now I am using in the spherical coordinate system. So in the spherical coordinate system we know that del dot a, del dot a vector for anything, part 1 will be come in the ISRO or not. Part 1 is also in the syllabus of the ISRO, right? There are 3 parts. I have split it into 3 parts. All 3 parts is basically in the ISRO examination. But right now I am dealing only with the part 1. Yes, but for the ISRO examination, part 3 is very, very important, right? Anil Kumar, are you getting my point? Shubham Agrawal, correct. Your answer is basically correct. Now, if we want to calculate this, then it will become 1 upon r square. This equation 1 upon r square h1 h2. We have write this equation in the previously. Right now, I'm using this one, r square ar, right? R square ar plus del upon del r. Del upon del r. Other function will be 0. Why other function will be 0? Because it has only one component in R. So if we'll write the other things, then a phi a z will become 0 because it does not have any phi or theta or phi value. So if we want to solve this equation, that is the basically AR. Now 1 upon r square del upon del r square. What about the value of AR? AR is nothing, it is just a k into r raised to power n. So if we want to solve this function equation 1 upon r square del upon del r, it will become k into r raised to power n plus 2. Now we can take the k outside, then it will become k upon r square, that is del upon del r. The function is r raised to power n plus 2, like this. Now if we want to solve it, so differentiation of r raised to power n plus 2 is nothing, it is just a n plus 2 minus 1. So it will become k upon r square into n plus 2 into r raised to power n plus 1. We have to subtract minus here. Now we can say that it is nothing, it is just a k into n plus 2 or r raised to power n minus 1. Why? Because it is in the denominator, that is r square. So we can say that this value, if we want to make this value 0, it is nothing, it is just a del dot a operation, right? Vector, del dot a vector. If we want to make this 0, how this function will become 0? Sir, only one thing, if the k will become 0, then that function itself having the value 0. So there is no need of any question. So to make this value 0, this quantity should be 0. So for delta a equal to 0, n plus 1, n plus 2 should be equal to 0. So n should equal to minus 2. Right? So Shubham, your answer is correct. Right? 1 month maybe preparation for GATE, I meant EMFT. Yes, EMFT. I am giving the very brief idea about the EMFT, right? So if you are thinking to leave the EMFT, just try to understand if the one question or one formula or any concept which we will discuss in the 4 or 5 hour of the EMFT class will comes in the GATE examination, that will directly help you, right? So if you are thinking to leave the EMFT class for the GATE examination, then it is basically very essential class for you, right? Vigneshwar, Sundarmurthy, are you getting my point? Now, what about the divergence theorem? That is also important. I am taking only the that topic or that question which is very or that important topic which is very important for the GATE examination, and the question which comes from in the GATE examination, I am taking only that topic, right? In the divergence theorem, a lots of questions will be asked in the GATE examination. Sometimes the directly formula comes in the GATE examination. What about the divergence theorem? So divergence theorem is nothing, it is just a closed integral of S in the surface. A dot ds is always equal to open integral of the volume del dot A dv. It means divergence theorem is nothing, it is just an approach in which we can calculate or we can transform the surface into the volume. So the divergence theorem is a basically transformation method by which the surface integral is converted into the volume integral, right? Just take the example, real life example. We know that in the closed integration of d dot ds is nothing, it is just a integral of volume integral of del dot d dv. That is the practical example we have used lots of place in the electrostatic, right? Related to the Gauss law, right? We have used lots of time Gauss law. In the surface, right? Surface to volume. If you'll see the Stokes theorem is nothing. Stokes theorem is also a transformation method in which the line integral is converted into the surface integral. So there is a line integral. We'll convert the line integral into the surface integral. What? By using this. By this, del dot a ds is always equal to a dot dl in the line integral. Real life example, h dot dl is always equal to surface in the line integral. If it is in the line integral h dot dl, line integral, then it is always equal to del cross h dot ds. So line is converted into the what? Surface, or we can say that the surface integral is converted into the line. Yes, definitely dear Ajay Kumar, yes, it is also useful for you, right? So just remember, divergence theorem and Stokes theorem is important for a gate examination. Just try to solve one or two more question in the your practice sheet for that will give you the more confidence regarding to the divergence theorem and the Stokes theorem. Now move on the electrostatic, right? Yes, transmission line is also important. We'll discuss the transmission line in the part 2, that is in the tomorrow class, right? Now in the electric field, if you see the electric field, in the electric field there is only the two parts. One is the Gauss law and another one Coulomb's law. Gauss law and the Coulomb's law. You will get every formula, every derivation by these two methods only, right? So in the gate examination, it will not possible that directly formula based question will be asked. Sometimes they will ask directly the formula based question, but sometimes you have to use your basic concept. So just look at the Gauss law and the Coulomb's law, and if you have the good command on Gauss law and Coulomb's law, then you will get, or you will calculate, or you will derive every formula related to it, right? I'll give you the brief idea about this, and after that in the last of the session I'll give you the short summary related to electrostatic and the magnetostatic and all the formula which is very very important for the electrostatic and the magnetostatic, right, in the tabulation form I'll give you, right? In the electric field we can say that D, that is the field density. So electric field density D is nothing, it is just like epsilon E, right? Epsilon is nothing, it is just a what? Sir, permittivity of the medium, and unit of the epsilon is farad per meter. Sir, what do you mean by permittivity? Permittivity is nothing, it is just the ability of the any material. It is the ability of any material to hold the electric field, or how they are passing the electric field, right? So it is, epsilon is basically related to what? The electric field, and there is another parameter that is called permeability, mu. Permeability is basically related to the magnetic field. So epsilon basically gives the idea how the material or how the metal will deal, or how any system will deal with the electric field, and mu basically gives the idea about how the material will deal with the magnetic field. So it is related to the magnetic field, it is related to the electric field. And generally we have to use the value of the epsilon naught is nothing, it is just a 8 point. Epsilon is nothing, it is a epsilon naught into epsilon r. Epsilon naught is the permittivity of the air, and epsilon r is the permittivity of the relative permittivity. So epsilon naught is nothing, it is just a 8.85 into 10 raised to power minus 12, or generally we can use this formula so that it will give, or calculation will become very easy, right? Now that is the one thing that is important in the electric field, D equal to epsilon E. Sometimes we have to use another one, that is the Gauss law. In the Gauss law we can say that D dot ds. What about the Gauss law? Sir, Gauss law states that if any charge, or we can say that in the Gauss law we can Gauss law in the we can say that net flux of an electric field, net flux of an electric field is in the closed surface is directly proportional to enclosed charge. It means if there is the enclosed charge Q, so if we'll see the electric field, that is plus charge, so electric field is nothing, it is just radially outward from it. So electric field is nothing, it is just radially outward from this. So the net flux of any charge, net flux of this thing is always proportional to the charge enclosed by the surface. It means phi is possible only when what? When the close is basically the surface is basically the close. Now we can say that by this formula, by this concept, we can say that, or generally we can say that phi equal to Q upon epsilon. Phi is nothing, it is just a Q upon epsilon. Phi is what? That is the flux. Q is nothing, just a charge, and epsilon is nothing, it is just a permittivity of the material. So we can say that at this case, total flux is directly proportional to the charge enclosed by the surface. And one thing more, if any surface is basically closed and charge is at the outside of that surface, then the electric field nature is like this. So an electric field which is entering into the surface should leave to the surface from the surface also. So net enclosed charge of this surface will become always 0, right? That is called a Gauss law, right? So Gauss law is applicable only for the closed surface. Is the surface closed? Sir, what happened when the surface is not closed? Let example, if surface is not closed, then if there is the charge plus Q, then there is the only entering electric field is possible. So we have to check the cross section, or we have to take the charge on this closed section only, right? In this section also, right? But it is not a Gauss law, it is something else, right? It is something else. Now, or del dot E, you should remember del dot E equal to rho V. So there are two things. One is the Gauss law, that is d dot ds equal to phi total flux inside the flow, or that total flux total is nothing, it is just a what is equal to Q. On del dot d nothing, it is just a rho V. Rho V is nothing, it is just a charge per unit volume. So if we want to, rho V is nothing, it is just a charge per unit volume. So charge unit of this thing is, unit of rho V is charge, that is Coulomb per meter cube. So if you rho V is given in the any problem, there is the rho V, and you want to calculate the charge, you have to multiply the rho V with volume of that function, right? Or volume of the surface, volume. If you multiply this thing, the volume, you will get what? The coulombs, or we can say that you will get the charge. Now electrostatic field, that is the Coulomb's law, that is also very, very important. Coulomb's law, if there is the two charge, that is Q1 and Q2, Q1 is placed at A and Q2 is placed at B, there is the coordinate system, or R vector of the A position is R1 and the vector of the B position is R2. Then the difference between the vector of this is R, or R is nothing, it is just a R2 minus R1. Now what about the Coulomb's law? Coulomb's law is applicable when the charge is placed on the what? On the same alignment, right? Now we can say that F is nothing, it is just a 1 upon 4 pi epsilon naught Q1 Q2 upon R square. We have discussed this, we know this formula since 12th class, right? And that is the unit vector of R. If you want to calculate or unit vector of R, then it is nothing, it is just a vector of R upon magnitude of R, or magnitude of R itself is R. So I can write this thing like this. So at the place of R, I'm writing R vector upon R, then it will become R cube, right? Now, if we want to calculate the electric field, if we want to calculate the electric field due to point charge, if you want to calculate the electric field due to the point charge, then it will be, here I am placing basically the Q, and from the R distance there is a point P2, and I am finding the electric field at this point. So if we are finding out the electric field at this point, then first of all we have to know the R vector, from this point, reference point, to the test point where we want to calculate, or that is basically where we want to calculate the electric field. So that is plus Q, and total distance is basically R. So we can say that R vector is nothing, it is just if it having the R2, it having the R1. So we can say that R vector is nothing, it is just a R2 vector minus R1 vector. Now F equal to QE, Now if you want to calculate the E, then it is nothing, it is just a F upon Q. So we have to remove one Q from the F, you will get what? The electric field. So in the electric field, I'm writing only one charge, Q upon R square. That is also R cap, that is the R unit vector of R. If I write the unit vector or direction in the form of the vector, then the R vector, again we can say that it is R cap is, again we can say that R vector upon magnitude of R. So we'll get this formula. Now the electric field due to the infinite line charge, right, that is called rho L. We should remember this formula for infinite line charge. Whenever the infinite line charge is given, then we have to use this formula. Rho L is nothing, it is just a line charge density, or line charge density we can say that per unit of rho L is nothing, it is just a Coulomb per meter. So per unit meter, how many charges basically distributed is given by the rho L. So if we want to calculate the complete charge on the line, you have to multiply with the length of that wire, you will get the charge. But at this moment, you should remember, I'm just writing that formula, which is very, very useful, right? Make a short notes, you will just write it. Now, in the next we'll move. That is the electric field due to the infinite sheet charge in XY plane. If I'm sketching the sheet, it is a sheet, right? And the sheet, if we'll say we want to calculate the electric field, and there is the charge distributed on it, then electric field will be looking like this, in this direction, Z direction. What is the basically value of Z? It will be upon 2 epsilon, right? But it is the positive only in the Z direction. If you will go on the minus Z direction, in this direction, then it will become what? Minus sigma upon 2 epsilon. That is when Z is less than 0. Just remember these two things, which is very useful for the GATE examination. Now, electric flux density, D. We have used this electric flux density. We know that electric flux density by the Gauss law formula, we can know this thing, right? D dot ds is nothing, it is just a phi, right? Or flux upon total charge. Total flux upon total charge. Or we know this thing. And D is, we have derived that formula, E is nothing, it is just a Q upon 4 pi epsilon R square and that AR cap, right? That is the direction. If we want the right D is nothing, it is just a epsilon E. So just multiply with E epsilon, you will get the D. So if we want to calculate the D, so just remove the epsilon from this equation, that is 4 pi R square AR, you will get it. You will get this formula, right? How much have you covered so far? I'll cover electric flux density and few topics related to magnetic field density, right? On one or two question, which is very important. But yes, in the next class, tomorrow class, I'll discuss only the question, not the theory. And I'll use only that formula which we have discussed in this class and only one or two formula which we'll discuss in the next class. Energy. The kinetic energy is basically given by half mv square, we know that, right? And the potential energy is nothing, it is just a q1 into q2 upon 4 pi epsilon naught r square, which is basically given by what? The potential energy. That is the kinetic energy formula, it is the potential energy formula. I am not deriving the subject, right? Why I am not giving the derivation? I am not giving the derivation because it is basically just a crash course, or we cannot say that it is a crash course. It is just a quick revision class. So in the quick revision class, I am just summarizing the formula of the EMFT, and after that we'll discuss some question related to that topic, particular topic, right? Now solve the one question, that is latest GATE question, that is this question is, electron Q1 is moving in free space Very good question. Just solve this question. An electron Q1 is moving in free space with the velocity 10 raised to power 5 meter per second towards a stationary electron Q2 far away, right? It means Q2 is basically far away and Q1 is moving, and these two things is nothing, it is just an electron, right? Moving towards Q2, which is very far away, right? Once again, I am reading this question. An electron Q1 is moving in the free space with the velocity of this electron is also given, that is called 10 raised to power 5 meter per second toward the stationary electron Q2 far away, right? Now, the closest distance that this moving electron get to stationary electron before the repulsion force diverts its path. It means it is also same charge, it is also same charge. When this charge is moving, then we have to find out the distance r. We have to distance r from these two charges, so that they will feel the repulsive force, right? They will feel the repulsive force and the direction of the electron will change. We have to find out these things, right? Again, I am reading. The closest distance that this moving electron get to stationary electron, right? Moving electron will become stationary electron, and after that electron before the repulsive force diverts its path, right? At what position this electron will become the stationary electron? That electron stop moving. We have to find out the distance at that particular instant. We have to find out the distance between these two electrons, right? So D is independent of epsilon in that formula only, right? In that formula only. But D actually depends, Coulomb element, D actually depends, right? One question, सर अगर ग्रेड अप का आज मंथली टेस्ट लिया तो 30, yes, it will valid for the 30 days, right? Okay. If we want to solve this question, just look at, there is a charge Q1 and there is a charge Q2, right? We know that in the initial state, at the initial level, the Q1 having the charge at the initial level, the kinetic energy equal to half mv square, because it starts to moving. And what about the potential energy? Potential energy is nothing, it is just a zero, right? Because it's in the accelerating field, it is just a moving. Now finally, when this electron will stop moving? At this instant, they have this electron have only the potential energy. It does not having the any this electron does not having any what? This electron does not having the kinetic energy, because the kinetic energy is basically gained by the electron when it is in the moving state. So we can say that in the finally, kinetic energy equal to 0. And what about the potential energy and the final state? The potential energy formula is, we have write that formula of the potential energy, that is Q1 Q2 upon 4 pi epsilon naught r square. Q1 Q2 upon 4 pi epsilon naught r square. And by the conservation of energy, we know that the law of conservation of energy, the initially energy or initial energy is always equal to final energy. By the conservation of energy, initial energy is always equal to the final energy. Now we can say that, at this case, we can say that initial energy is equal to the final energy. What about the initial energy? Sir, sum of this energy, half mv square plus 0. Then it will become half mv square is plus 0. So I'm not writing the 0. And the final energy what? Sir, Q1 Q2 upon 4 pi epsilon r square. Right? Now what value we have to calculate? Sir, r. Right? So if we want to calculate the value of r, just use the formula of r. at this case, right, we have to use the formula of R, and everything having the value mass is basically given, right? Put the value of mass is given 9.11 into 10 raised to power minus 31. Q1 is given, Q2 is given, Q1 and Q2 is nothing, it is just a minus 1.6 into 10 raised to power minus 19. So just make the square, it will become the plus 1.6 into 10 raised to power minus 19 square. Permittivity is, use this formula 1 upon 36 pi into 10 raised to power 9 minus 9. You have the only one unknown quantity, that is called what? And velocity is also given there. Velocity is nothing, it is just a 10 raised to power 5. So in this case, only one quantity is basically unknown, that is called R square. Right? In this case, only the one quantity is given, just a R square. Okay, just forget about this. It is not a R square, it is R. Q1, Q2 upon R. Because it is the energy, now you have to multiply with R. So it will become R. So in this case, just forget about the formula of R square. It is not a R square, it is just a R. Right? Just a R. Q1, Q2 upon 4 pi epsilon R is called what? Is basically formula of the potential energy. Use this formula and get the value of R. Just give me the answer as fast as possible. Right? R is nothing, it is just a 5.063 into 10 raised to power minus 8 meter. So 10 raised to power minus 8 is given. So the answer will be what? 5.063. 5.063. 5.063. The basically answer of this question. Right? Now we'll move on the next topic, that is called work done calculation. If we'll deal with the work done calculation, then work done calculation is nothing, it is just a what? VB minus VA equal to E minus E dl, and if there is a VB minus VA, then we have to use A to B, right? E dot dl. And work done is nothing, it is just a W is nothing, it is just a Q VB minus VA, and we know that VB minus VA is nothing, E dot dl. So I'm just replacing this value at this place, so it will become minus Q A to B E dot dl. One question will be asked in the GATE examination, in the GATE exam also regarding to this formula only, E dot dl. Right? This is also a useful formula. Sir, Q2 in question, both are basically the electron dear. In the previous question, the both Q1 is also electron and Q2 is also electron. That's why I'm taking the charge of the electron itself, right? Now, equipotential surface. What is the equipotential surface? Sir, equipotential surface, it means from this point to this point, the difference in velocity, that is del V, then we can say that from this to this point is also is the del V, right? Difference between the potential or different potential difference. But that is not a useful for us. Electric field, basically equipotential surface means what it indicate? It indicate that E dot ds equal to 0. Surface vector and the electric field vector is basically perpendicular to each other. It means in the problem basically if the question is not directly comes from the equipotential surface, it will not directly comes. Question will comes, and in the question there was the word which is mentioned, that is equipotential surface is used. By the equipotential surface, we have to understood, we can use this concept whenever the equipotential surface is given, or we can say that if the direction of E is given, we should take the direction of ds as a perpendicular of it. That is the important thing, right? We have to use an equation. So equipotential surface is nothing, it is just about E dot ds equal to 0. It indicates that electric field is perpendicular to the surface. Now dipole, we know that whenever the two charge which is placed very near to the each other, having the opposite charge basically placed near to the each other, then they will form the dipole, right? And dipole is P nothing, it is just a Q into length into charge into length, and charge, unit of charge is nothing, it is just a Coulomb, or unit of the length is nothing, it is just a meter. So the P is nothing, it is just a what, Coulomb into meter, that is the unit. And the direction is very important, from minus to plus, right? Minus Q to plus Q, it is in the direction. That is the direction of what? Dipole. Or generally the dipole is written like this, P equal to Q dot dl. It is also a vector quantity, that's why I am taking the direction, right? One question, सुफियान अजहर, सर क्या 2 महीने में 60 नंबर लाया जा सकता है? बिल्कुल लाया जा सकता है दोस्त, क्यों नहीं लाया जा सकता है, बट आपको थोड़ा सा प्लान करके चलना पड़ेगा, राइट? अगर आपने प्लान नहीं किया तो फिर दिक्कत आएगी, आपको थोड़ा सा प्लानिंग करनी पड़ेगी, और अगर आपने प्लानिंग किया ढंग से तो फिर आपका हो जाएगा, कोई दिक्कत नहीं, राइट? और इलेक्ट्रॉनिक्स के अगर आप हैं तो 60 मार्क्स में आपकी बहुत अच्छी रैंक आ सकती है, बट एक प्रॉपर प्लानिंग होनी चाहिए। कम्युनिकेशन आप नहीं छोड़ सकते, you will never leave the communication, you will never leave the signal system, digital electronics signal system, control system, and analog electronics, right? Because it has the more weightage. Obvious, mathematics is also very important. 5 to 6 subject you should have a good command, right? So 2 month को आप split कर सकते हैं लगभग 10-10 दिन के पैकेज में, और 10-10 दिन के अंदर आप कोर्स के जो इंपॉर्टेंट टॉपिक है उसको आप कवर करके अचीव कर सकते हो, अगर प्रॉपर प्लान में काम किया जाए तो। Now the dipole is basically, I am taking the 3 type of dipole: monopole, dipole, मतलब basically the configuration of the poles. One is the monopole, dipole and quadrupole. In the monopole there is the 1 charge, on the dipole there is the 2 charge, and the quadrupole there is the 4 charge, which is in the form of plus and minus, right? Most important जो चीज़ है वो है, in the monopole the basically the potential is inversely proportional to R. And electric field in the potential is also, there is the one difference between the denominator R. So we can say the electric field is inversely proportional to 1 upon R square. In the dipole, the potential is inversely proportional to 1 upon R square, and electric field is inversely proportional to R cube. In the quadrupole, the volume potential is inversely proportional to R cube, and the electric field is inversely proportional to R raised to power 4. Sometime the question will be asked from these concept also, right? That is important. Now, along with this, you should remember these some points also. One, for sheet 1, for disk, how to calculate the electric field when the charge is distributed on the disk. So one formula related to disk also you should remember. One is ring. Question sometime asked from the ring also. And the third one, hollow sphere. Just like a ball. So electric field, electric potential, and the electric field density, that is D. All 3 things you should remember how to calculate for disk, ring and hollow sphere. Right? Now, that is the magnetostatic. I earlier said that in the electrostatic only the 2 things are important. One is what? One is the Gauss law, and another one is the what? The Coulomb's law. All the formula, electric field by the line charge, by the surface charge, by the volume charge, we can, volume integral, volume surface, we can find out by using any of the formula, by the Gauss also, and by using Coulomb's law also. Same as the electrostatic, in the magnetostatic we can say that there is 2 things only. One is the Biot-Savart law, another one is the Ampere's law, right? We can calculate everything by these 2 formula only, right? In the Biot-Savart law, whenever a line or a wire having the current I, then if we want to calculate the magnetic field density B, right, at this point P, then it is basically given by mu upon 4 pi I dl into R upon R cube. And yes, this is also a vector quantity, so the direction is very, very important. So direction is nothing, it is just a I dot dl direction. It is also a directional cross R direction. A direction of this is basically nothing, it is just like this. Now, Another one is the Ampere's law. If we'll move or we'll see the Ampere's law. Ampere's law is nothing, it is just a H dot dl is equal to I enclosed, right? It is the integral form of what? Ampere's law, right? And H dot dl is nothing, it is just a, we can also write H dot dl equal to, that is an L. I'm converting the line into the surface integral, right? I think you all remember. You all should remember about this thing, how the line integral is converted into the surface and how the surface is converted into the line, right? Everything. Now, I one another parameter, it is I, and I is also in the surface, that is called J dot ds. We can calculate I also. These 1, 2, and 3 formula is very useful in the magnetic field, right? One question will be asked, sir, EMFT में एंटीना थ्योरी प्रॉब्लम दे रहा है, उसको कैसे सॉल्व कर सकते हैं? कर लेंगे दोस्त, उसको करेंगे, हम देखेंगे, डिस्कशन करेंगे, टेंशन मत लीजिए उस चीज़ की आप. राइट नाउ, यस, surface current density, that is J is nothing, it is just a surface current density Js. It is also, we can say that del cross H is nothing, it is just a Js, right? Now there is the force in the magnetic field. If we want to calculate the force in the magnetic field, if the charge basically in the static magnetic field, there is two type of, right? In the static magnetic field, when both the electric and magnetic field both are present, when the only magnetic field is present, when only the magnetic field is present, then F is nothing, it is just a force equation is given by Q V cross B. But at the particular time, if the electric field and the magnetic field both will present, then we have to use the Lorentz force formula. That is F equal to QE. It is from the electrostatic, and this is from the magnetostatic. So we have to combine to get the complete force of this function. Now I am just summarizing everything, right, which we have discussed. Oblique इंसिडेंट पे बात कीजिए, बिल्कुल करेंगे दोस्त. अभी तो वहाँ तक पहुँचे ही नहीं हम, अभी तक तो बहुत बेसिक चीज़ें, और आपने देखा होगा we are not discussing in very much of detail. I am just giving the formula so that that will EMFT और subject EMFT will be brush up, right? कुछ चीज़ें आपको याद हो जाए, एकदम दिमाग में जो चल रहा था सब कुछ अरेंज मैनर में हो जाए, इसलिए मैंने ये सारी चीज़ें करवा दी, और इस टेबल से आपको और सारी चीज़ें क्लियर हो जाएगी, राइट? क्या हो जाएगा क्लियर? तो देखिए, मैंने दोनों ही चीज़ें इलेक्ट्रोस्टैटिक और मैग्नेटोस्टैटिक को मैंने दो पार्ट में स्प्लिट कर दिया. In the electrostatic rho L, line charge density, that is the line charge density rho L, and charge is basically calculated by the rho L is nothing, it is just a rho L into dl, right? We have to integrate it, you will get the complete charge. Now in the magnetostatic there is no any small value like rho, right? Any small point, it is just a dl, and the smallest unit of what? Smallest things in the magnetic field is nothing, it is just a IDL. I is nothing, current, dl is the length or wired length or small or differential wired length, dl. Now if you want to find out the surface, rho S surface charge density Coulomb per meter square. If we want to calculate Q, so just we have to integrate of rho S, you will get what? Charge. Here it is a GS, that is surface charge density. If you want to calculate, just multiply it with the surface. Now rho V is the volume charge density, Q equal to rho V dV, and here we have to multiply J, that is called JV, right? JV is nothing, it is just a volume current density, right? The unit of volume current density is nothing, just a ampere per meter square. And if you want to calculate the current, then you should multiply with what? dV. Now it is the electric field equation, we have seen that. It is the DH equation, we also seen that this equation. Now field E in the form of the vector, we can write like this, in the form of this is like this, right, in the integral form. That is only dH na. If we want to calculate H, we have to integrate this function, right, in the complete integration, right, in the complete length of the wire, you will get. Now direction. So electric field E direction is always radially outward. but the H magnetic field direction is along IDL cross AR, right? That is normal to the R. That is called the normal to the R. Fourth equation for the electric field, we can use F equal to QE. In the magnetic field, you use this one only, F equal to Q V cross B. When the infinite length current, electric field nothing rho L upon 2 pi epsilon rho, and for the magnetic field it is just like this, I upon 4 pi rho A phi direction, right? It is basically the formula we have to use. And generally the formula is for the electric field H equal to I upon 4 pi rho cos alpha 2 minus cos alpha 1. If it will become the infinite length, then what happened? Then the alpha 2 will become what? Then the alpha 1 will become 0. Sorry, alpha 1 will become what? 180 degree, or alpha 2 will become 0 and alpha 1 will become 180 degree, because it will become the infinite length. If it will become the infinite length, it is just like the what? That point will present on this point only if it will become the infinite. So we can say that 180 degree, if we'll put this value, H is nothing, it is just a I upon 4 pi rho A phi. And what is the basically direction? DL into AR direction. Right, now the electrostatic. In the electrostatic, the infinite sheet is present. If the infinite sheet is present, then E is nothing rho S upon 2 epsilon. We have seen that, right, in the positive direction. And if the magnetic, this type of sheet is present, then we can say that HI P square AZ, in the AZ, upon 2P square into H square 3 by 2, rep power 3 by 2. Here the H is nothing, it is just a what? If we want to circular loop, right? If we want to calculate what? The magnetic field by the circular loop, then we can say that I P square AZ rho Z AZ 2P square H square is to power 3 by 2. Here P is nothing, it is just a radius of the loop, right? Radius of the loop, that is called P. It is called P. Right? H is nothing, it is just a located, H is where? It is located on the axis. In this axis we are calculating this. Now D is equal to epsilon E, B equal to mu H, we know that. Now for the potential, we know the formula, V equal to Q upon 4 pi epsilon R, and here A is nothing, it is just a what? Integrate mu I dl upon 4 pi R. If we want to calculate the flux, then D dot, if the surface is closed, then D dot ds equal to phi, and if surface is not closed, then that will be the E phi open, right? And charge, we can also calculate the charge by, we know that Q is nothing, it is just a CV. So by enclosed charge we can also use by this formula, Q equal to CV. But at this point we can say that the flux, magnetic flux, is basically calculated by B dot ds in the surface integral. So phi is nothing, it is just a Li, right? In the magnet, the magnetic field, outside the magnetic field will be from north to south, and inside the magnet, the magnetic field is from south to north. That is the basically direction of electric field. Now energy density, or we can say the energy half D. If we'll put D equal to epsilon n, then we'll get half epsilon E square, and it will half mu H square. Now that is Poisson vector, not position vector, position equation. It is Poisson equation. Del square V equal to minus rho V upon epsilon, and if rho V equal to 0, then del square V equal to 0. You know this equation earlier. We have discussed this equation, right? Already we have discussed this equation. That is the Maxwell equation, right? You should remember the Maxwell equation. That is the nature of the time varying field, right? Del dot D equal to rho V, del dot B equal to 0, del cross E equal to minus dB by dt, del cross H equal to J plus del D by dt. Here J is nothing, it is just a conventional current density JC, or we can say that del cross H equal to JC plus JD. JD is nothing, it is just a displacement current, right? So if we want to calculate the JD is nothing, it is just a what? JD is del D by del T. So if JC for the sinusoidal, if JC and JD for the sinusoidal case, if the sinusoidal signal is applied, then JC current density, right? JC is nothing, it is just a sigma into E. We have seen this thing in EDC. You have already studied about this thing in EDC. And if you want to calculate the magnitude of this function, then JC magnitude is also sigma E. Now JD is nothing, it is just a what? You have to integrate it, right? So omega E in the sine or in the maximum value, if it is the oscillatory nature, take the example just like sine omega t. So if we'll integrate it, you will get, it will differentiate it, then you will get what? Omega into cos omega t in the magnitude. And cos omega t, I am taking 1, so it will become what? This value, omega epsilon into E. And if someone say that, if the current, conventional current or the displacement current will same, if I suppose if taking the case in which the conventional current, conventional current density and the displacement current density will become same, then we can say that sigma E is equal to epsilon E, or omega is nothing, it is just a what? Sigma E upon epsilon E, E cancel out, or omega is nothing, it is just a 2 pi f. So at this case we can say that f equal to sigma upon 2 pi epsilon. It is the condition of frequency. It is also important. It is the condition of frequency at which we can say that, it is the condition of frequency at which we can say that the conventional current and the displacement current density, conventional current density and the displacement current density both having the same value. Both having the same value, right? Now there are 2 questions which is I am giving to you. In the next class we'll discuss that question. Just practice for that question. First question, take a snapshot for this question. Just take the snapshot of this question, and now and take the snapshot of this question also, right? These 2 questions is important, right? Just take a snapshot of this question and try at home. After that we'll discuss this topic in tomorrow class, right? And I'm saying it is not a EMFT, right? I'm not teaching the complete EMFT. I'm just giving the brief idea about the EMFT, some formula, some concept, so that the problem solving capability will be developed. I have taken only those formula. You know the EMFT, in the EMFT there are lots of formula, but I am taking only those formula which is important for the GATE examination, right? One question, sir, what is the magnetic scalar potential? We'll discuss that thing, right? Till that, it is also already the overtime. So till that, thank you very much, right? All the very best, dear.